and these things are different these things are different between tissues. Yeah. So a transcription factor can activate mainly euchromatin. I think so it's pretty simple. So the
就是缠绕程度，
Yeah,
每
yeah,
个东西都
yeah,
不一
yeah.
样，然后就是导致结合的。
反正你要打开它才接得上去。
Yeah,
所以它就算接得上去，这几个 sequence 在你这个地方你要打开，它才有办法去 activate 这边的 transcription。
So we currently suppose that what neurons insulin signaling pathway is as same as other tissue, but because this kind of difference is in the gene expression, so they can do different things. That's the case here. Okay. Right. So this is insulin, and insulin is pretty simple peptide, and composed of two chains. Okay. This shorter one is chain A, and this one is chain B, and chain A is the pink color here, and chain B is this blue color. Okay, and you can see that. Oh yeah, I didn't show it here. Okay, sorry. So it has three disulfide for each. Okay, two between chain A and chain B, and one is chain A intramolecularly. Yeah. So yeah, that's kind of the structure here. You can see that this is only like 50 something peptide. Pretty simple peptide, yes. And however, in the history of scientific research, the guy who saw the primary sequence of insulin wins Nobel Chemistry Prize, and the other scientists who solved the 3D structure of insulin also win the Nobel Prize in Chemistry. Yeah. So yeah, this kind of research was 2 Nobel Prize. Yeah.
只是因为它是第一个吗？
Not sure. Well, the guy who saw the primary sequence is Linus Pauling. You might have heard of that. Nope. Okay, Linus Pauling. You know who Linus Pauling is? Nope. All right. So you might encounter his research in your general chemistry. Yes. Okay. He also did something about the peptide. Like he defined like alpha helix and beta sheets and some things like that. Okay. And the scientist who discovered the 3D structure of insulin is Dorothy Hodgkins. You heard of Dorothy Hodgkins? No. We mentioned about it in when we talk about the techniques. Yeah. The first session of our club. Yeah. We said that she pioneered it in solving 3D structure of biomolecules by X-ray. Yeah.
Oh.
Yeah. That girl. Yeah. Okay. And here is IGF-1, like insulin like growth factor 1. Okay, so the difference between it is that we say that insulin is only 2 chain, and however in IGF it has another chain called chain C that link the 2 chains from insulin. Yeah.
What is the difference between
Oh, we will discuss later that the receptor for IGF can also bind insulin, and insulin receptor can also bind IGF-1. So yeah, it's still under discussion, but it acts very differently physiologically speaking. Yeah.
但他们接种差不多。
They can also
So
it can only activate IGF-1 receptor.
And has a slightly activated insulin receptor. Yes. Due to the similarity in structure, right?
Slightly.
Yeah. yeah, but however, the IGF is more limited because in the circulatory system, it has IGF binding protein to inhibit it from going around.
那全名
Insulin-like growth factor. Yeah.
啊
A growth factor that looks like insulin, as you can see. Yeah. Okay. And yeah, you might also have learned that. What? Yeah, I
那
think
你到底对他接的比较慢嘛？
应该也国化不了。
low affinity. So yeah.
哦，
所以有一直没差。
Yeah. So you can only do this in visual, I think. Yeah.
所以它只是接上那个 IGF receptor，它是跟 IGF receptor 的 affinity 比较高。
Yeah, it's binds to IGF receptor.
哦，然后跟 insulin receptor 的
有一点点。
有一点点的。
Yeah, because if you do in visual experiments, you add a bunch of IGF-1 that is way more high than your physiological concentration, then it probably will bind. Yeah. And we did conserve that.
那那个浓度是正常身体会到达的。
No.
哦，
不然他就会只用一个就好了。
确实。而且
Relax.
我们可以用 IGF-1然后开医疗。
Yeah, wow. Yeah, so this one won't get you diabetes. Yeah, relax. Yeah. Okay. And oh, here is in our circulation system, insulin usually don't exist as monomer. Instead, is mostly dimer. Oh, sorry. This is monomer. Sorry. This is hexamer insulin. So usually it existed in this way.
Hexamer
六个啊，
hexamer
六个。
Oh,
Okay. 三四五六。
receptor can only
yeah, exactly. So
accept four.
So when insulin try to bind to insulin receptor, you have to dissociate first.
Why 6?
Well, yeah, it has a good reason. So
你要想一下，有可能是你的 insulin 它在血液中还是怎样，它会形成这样的形式，但是你在接到 receptor 的时候会再被解开。
对，
因为它感觉就只是接在一起而已。那如果你有一个 affinity 更高的东西，感觉可以把它，
他会把它吸走。
另把它抢走。
Yeah, that is right. Kinetically.
因为他们感觉接的也很，他们也没有很紧密的接触。
感觉比较类似，
就感觉就是轻便接而已啊。
所以它比较类似是，如果你要说举例的话，就类似像戴维斯4级结构，就是他没有说真的去把你在一起。
Yeah, of course. Yeah. And
但它可以，它会
so it's more like
它不会把你在一起。
其实4级也是不。
it's more like
不完全。
yeah, it doesn't have covalent interaction. Okay.
我记得4级不完全。
不完全的。
It doesn't have covalent interaction between 6 of these. Okay, and you can see here in a monomer you can have a potential to build beta sheets.
哎呀，4级可以包含那个，可以包含那个双硫键。
对啊。我在想4级有没有双
Oh, that's tertiary.
哦，3级超双。哦。好。
两个 peptide 中间没，如果有。
Yeah, you can do that, but
那比较容易被归为3级。
对，可能还是会算3级。
4级会基于3级的结构，3级的结构再去做 interaction。
就是我们通常不会这样讲不会这样对啊，就是你不会特别强调说4级结构里面会出现双螺旋，
因为我们通常讲的3级结构是我们把4级结构拆开来，每个 subunit 我叫它一个3级结构，对吧？所以我觉得3级结构是有介于4级结构的一个。
我觉得我一直觉得分级很奇怪。
但你很多个3级接起来，你也能教4级啊。
商业切入全化学系。
Okay. Oh yeah. So like here, it has a beta sheet to pair with another beta sheet in others.
为什么？哦，我以前为什么贝塔系它都会画
箭头
方向？
Oh, it has kind of directionality. Okay, because so you have like parallel, anti-parallel. Yeah, structurally it's kind of different.
那他们两个的结合力高跟低是有差吗？
No difference between these.
哦，它只是有方向性的。
Maybe it's involved more in protein folding or other aspect of the protein. Yeah. Alright. So now you know what insulin looks like. Very good. Then this is insulin receptor. Okay, so here is it's cotton graph and it's more 3D structure view of insulin. Okay, so let's see. So most of this is extracellular domain. Yeah.
应该那边台湾是开飞吧？
This.
哪里？
那为什么他不是写完是写？
Hold on. What happened?
PK。
Oh, yeah. This is
是台湾。
yeah, tyrosine. Yes. Y means tyrosine. Yeah. One alphabet short. Okay. So extracellular domain and intracellular
F
domain
是什么？
and
F1 所以这应该
靠边。
不稳。
let me see. Fibronectin like structure. Fibronectin like domain. Fibronectin. You know what it is, right?
Yeah.
Okay. So it's a protein that involved in cell adhesion.
啊？
Cell adhesion.
然后 cell adhesion，
Adhesion,
就是那
yeah.
个
To link two cells together.
adhesion 就
The
是
kind of, you know.
接待细胞上，或者是你就想它就平叠在那个，就是可能就是表皮细胞，那它就是一个 adhesion 在，很好的讲，一层一层。adhesion 就是那个。对，它就是这个。
So you know integrin, right? Integrin. 整合蛋白、整连蛋白。
integrate。
Yeah, it's also a cell adhesion molecule, and also fibronectin, and it will link to what's that? Proteoglycan. Yeah. Mainly it will link to extracellular matrix. Yeah. So yeah, but it doesn't have to have nothing to do with the fibronectin. It just look like yeah. And I kind of forget what it's true.
L1 就是1吧，然后就是那个你可能两个黑类是这样，还是什么不知道，应该是，然后
This part I can.
然后 F 就是刚刚讲的，
And
然后 IPN 就是 transmembrane domain， 然后 I 就是 intermembrane domain， 然后 TK 就是 tyrosine kinase。
this is JN.
JN.
Juxtaposed membrane means it's intracellular domain that is very near to the membrane. Yeah.
哦。那个 F 里面的东西在干嘛？
Well, it just yeah. It doesn't have a special function.
哦，它只是
Yeah,
跟它的
related to
形态
its
去
structure.
编号的。
Yes. And here this kind of furin is a protease. In the maturation of this protein, it has to cut at this site here. Okay.
你说他们在 monomer。
Yeah. So it's that's viewed as a monomer. Yeah. So during the maturation, it have to be cut. Yeah. But
哦，然后切开就是 monomer。
yeah. So when you first get out of the ribosome, it's a monomer. It's a monomer, and it's this long. Yeah. And it's one molecule. And however, it will be digested by furin. You cut it like this one. Here, furin is a protease. Yeah, I think that it is necessary that the furin is necessary to help receptor to be mature. Okay. Nope. Really?
Huh?
Really? I didn't know that. Yeah, maybe you guys can Google it afterwards. And oh, one interesting part is that it has an alpha C terminal domain. You know, this part of insulin receptor is alpha. What is it called? You know, alpha segment, and this is beta segment. Okay, and between the very end of alpha segment, there's an alpha CT, C terminal domain, and when it forms a dimer, they will form the intermolecular disulfide bridge between adjacent to the alpha CT.
TMPRSS2 上面吗？是吗？就是那个 TMPRSS2 就是会把那个SARS-CoV-2 的 S14 剪，然后剪完之后，它就可以跟ACE2剪，所以那个反应才就漏出嘛。
Yes.
Fury 是一直都在。
It's a genuine knowledge.
Fury 可以跟小姐啊，
Alright.
S1 S2。
Okay, let's move on. Okay, so when in apoform means that no insulin is bound to the IR, and it looks like like a U shape. Okay, and so you can see that it has a very strong intermolecular interaction between the blue one and the green one. You know, so intermolecular interactions. Yeah. Yeah. Yes, exactly. And also you can see that alpha CT of it says promoter 2 is here, alpha CT of promoter 1 is here, and you need to realize that there is some peptide and that links these two peptides. A short sequence of peptide, like here. This one. Yes.
我想说，还是说阿法贝塔吃的其实可以折。
My point is, there is disulfide bridge between the alpha CT of these two insulin receptor monomer. Yeah. So you need to realize that these two parts are somewhat linked covalently. It's hard to see here, but it does happen. So that's about it. Okay, and now let's view how 4-bound insulin receptor, meaning that they have 4 insulin on it, and you can see that it's pretty different from what we just saw, a U-shaped receptor, right? It becomes a T-shape, and with sort of. So we'll look at this.
哦，就是它的那个，它路冠折起来了。
So
就是刚那个是折在路的地方这样子，然后它路冠也这样折起来。
Okay, you can see the difference, right? Yeah, one is this, and the other one's kind of like this. So let's see where it's like in this. Okay, so this is it's like a T shape, and on the top of T shape there is 2 insulin binding sites here and here, and on the stick of the T it has other 2 binding sites. Yeah, we will discuss that, and yeah, and you can have your own comments about that, because we don't really know. Yeah, we don't really know if it has only 2 insulin spikes on it, whether it will activate.
因为感觉只要那两个比如说这样子，它应该就可以很类似这种东西。那我不知道，感觉那紫色就是刚好接上去了。
Yeah, but it has some kind of structural functions. Yeah.
这样的紫色是
这个是
对不起嘛，我不会形容颜色。
Alright.
然后桃红色好不好
Then so this is between two IR monomer. Yeah, so we call it hybrid sites. And in the stem of the T here, this binding site is only mainly involved one chain of the RTK only. So that's a bit different. And when all the ligands is on it and this like fibronectin like domain will have a strong interaction. Therefore, the intracellular domain will also can come together, and they will do auto transphosphorylation. Yeah, and then this RTK will be activated. Okay, that's pretty easy to understand. But next we are going to discuss how how we can from this to this. Yeah. So it should be a stepwise case because you can.
它同时受体了。
Yeah. And this is same on. All of them are extracellular domain.
它底下稍微蓝小，它这边好。
Oh, yeah. I should clarify this first.
泡沫在那个血管。
All of them are extracellular domain.
是吧？所以然后它最底下那个是 F 3的，是吧？
And for intracellular domain, there is some kind of we need some kind of special techniques to determine its structure. Most of the proteins cannot do this, so we mostly the extracellular domain refines very well, but for intracellular domain, doesn't really can refine it. So
那为什么这个全部？那我们是可以合，我们是可以合出那个然后再把它分离出来，然后算。
for membrane protein, you always have to have a membrane to stabilize it. So
因为它从合成的时候就拆了上。
So you see this is pretty hard. Okay. Now, so they propose here that when only one binding of this one RTK will kind of go back and the other remains the same, and then generally it forms a symmetry T shape. So because I think I didn't mention it, but upper binding site we call it site 1, and lower site we call it site 2. Okay, so because site 1 has higher affinity, just like you supposed, higher affinity in binding insulin. So mostly the first 2 insulin should bind into site 1, and so it will induce first tear the kind of change their conformation to make it more closer. Yeah, so may oh yeah, this one. And then 2, and then they will kind of becoming a more like a T shape. And let's see what happens. Because what we think what site 1 do is to release them from being auto inhibitory outdoor inhibited, which means their intracellular domain is too far away to come close together. Yeah. Okay, so yeah, what's when site one just bounce on it and you know there is a very dramatic conformation change there, so leads to this, and you can see that this is way more closer than the U shape. So yeah, I think maybe you are right. 2 insulin might be adequate to activate the tyrosine kinase.
But why do this? 就多的嘛，这样。
You know,
它上面它塞忘的是1000多，
对，
就1000多，所以它下面塞理论上应该，它也会有，拜登上应该也会有跟差不多。哇哦，哇哦，
我把投不上去了。啊，那个抗性啊，尴尬。Okay, so let me show this. Right.
哦，所以确实，哦，它也会有一
Yeah,
点。
you're right. So from top view is one letter
从
from
前面
this.
看的话，它会感觉好像在这边，它其实还是有，它还是稍微有一点偏左。
Yeah, exactly. And so same for these two. And yeah, I might as well move on with this. Okay, so you can see here it interact with the green chain here and alpha CT domain of the silent chain here. Yeah, so we call it a hybrid site. It's right between the two RTK.
So these two monomers, their amino acid sequence is different.
Maybe the same.
But why? But their conformation.
Yeah, because you have to think that when the conformation is different, it's happened at only one insulin is bounded.
Yeah.
So it can only bound to one of either of site one. So you can see that there has to be a conformation